In this video, we're going to talk about operation with integers, and we're going to talk about multiplication and division. Before I do that, though, I want to just make a remark about something I said in the last video where we talked about operations with addition and subtraction. So, if you have two numbers, I just want to clarify this. I mentioned it in the last video. If you have two numbers and you're adding them, there's a couple different situations. I'm going to make bigger numbers now. The number with the greater magnitude could be the negative one. It could be the smaller one. Or they both could be negative. Now, we already talked about if they're both positive. You should know how to add the numbers if they're both positive, just based on what we covered in the earlier part of the semester. So, you don't want to have to draw a number line every time. When you're teaching students, younger students though, and you start out adding numbers like 5 plus 3, negative 5 plus 3, you can show them how it works on the number line. You can show them how it works with counters, but when you get up to bigger numbers, you're not going to want to have to draw a number line or draw that many counters. So what it amounts to is if you have two positive numbers, like 26 plus 20, you add them and the answer is positive. If they're both negative, what you can do is just pretend that they're both positive. Add 26 and 20 is 46. But since they were both negative, the answer is negative. Okay? So you don't have to draw a number line or counters for that. If they're opposite sign, doesn't matter which one, if they're opposite sign, one's positive and one's negative, just subtract them. So 26 minus 20, always just take the smaller number away from the bigger number. So 26 minus 26, but since the number with the greater magnitude was the negative number, the answer will be negative. Then same here, 26 minus 20 is 6, and since the one with the greater magnitude was positive, the answer will be positive 6. So I mentioned that in the last video, but I just wanted to make sure I clarified it. So I don't expect people to draw pictures. Like if I asked you to add negative 131 plus 29, you don't have to draw that out. You should just, let's do that problem. 131, negative 131 plus 29. Well, since one's positive and one's negative, I'll subtract. I'll just pretend that they're both positive, or maybe pretend's the wrong word. I'll just imagine that they're both positive, subtract, so you get 102. But then since the one with the greater magnitude is negative, it'll be negative 102. So yeah, I didn't have to notice I didn't draw a picture for that. I just did it. Alright, I just realized I'm not wearing my glasses. It feels kind of strange. But I'm not looking at any notes, I'm just drawing on the board. Alright, if I had to look at notes, I'd probably need my glasses. Now let's talk about multiplication. So luckily you know how to multiply two positive natural numbers. We've gone over that in previous classes. So you know how to do 5 times 3. First of all, it's a mathematical fact. If you drew a multiplication table, 5 times 3 is on that table, and it's 15. Okay. So if they're both positive, the answer will be positive. So here we have a similar problem, except for it's negative 5 times negative 3. Well, if they're both negative, you can just, I don't want to say assume that they're both positive, but if they're both negative, the answer is going to be positive. You can just multiply 5 times 3. and it's 15. So in both the cases where the numbers have the same sign, the answer or the product will be positive. So if two numbers have the same sign, sign is in S-I-G-N, same parity, I guess you could call it too. If parity just means like negative or positive. It can mean other things too, but in this example it means that. So if they're both positive, the answer will be positive. If they're both negative, the answer will be positive. And you basically can disregard the signs, say, well, it's just like 5 times 3 if they're both negative. It's 15. Well, when one of them's negative and one's positive, it doesn't matter which one either. When one's negative and one's positive, you still can disregard the signs, multiply 5 times 3, but then the answer's, the product will be negative. So when they have different signs, product is negative. So that really sums up how to multiply two integers. Okay? There's no other real situation except for 0, right? If you multiply something by 0, the product will be 0. Doesn't matter what. I could say 8 times 0, that's 0. I could say 8 to the 8th power, to the 8th power, to the 8th power. Whatever that huge number is, times 0, that's 0. I'm going to have to look up what 8 to the 8 to the 8 to the 8 to the 8 is. Probably a astronomically huge number. But if you multiply it by 0, it will be 0. Okay, so let's talk about division. So operations with integers, division. I'll probably use the same numbers like 5 and 3 again. So you could have 5 over 3, or 3 over 5. That's 3 over 5, not 5 over 3. Oh wait, actually I want to show it like how I've been showing it. I don't want to, you just got a spoiler alert there. Alright, so you could have 3 divided by 5. You could have negative 3 divided by 5. You could have 3 divided by negative 5. Negative 3 divided by negative 5. So, in the top one, how would you write 3 divided by 5? Well, I know a lot of you would just write, well, 3 divided by 5. You would plug it in the calculator. Sorry, I think there's something different about the camera today. I used to be able to walk over a little bit over here and I'd still be, I think somebody might have moved this, I don't know. So 3 divided by 5, you type it in your calculator, it gives you 0.6. You shouldn't really have to type it in your calculator, but I guess division is in some ways the more difficult of all the operations. But one thing you can do without even typing it in your calculator is you can just write it like this. 3 divided by 5 is 3 over 5. Okay, we haven't talked about decimals yet, so for right now, that's how I'm going to write 3 divided by 5. Negative 3 divided by 5. Look like that. 3 divided by negative 5 would look like this. Now negative 3 divided by negative 5 would be negative 3 over negative 5, but the negatives cancel out. The negatives are just represent the number negative 1. So they cancel out and you're left with 3 over 5. So basically the same as multiplication. If they have the same sign, the quotient is positive. If they have different signs, like these two, quotient different, sign, quotient, negative. Okay, so if they have different signs, the quotient will be negative. So let me talk about those two examples actually. I'll get rid of the ones that are boring because they're positive. So where this negative sign is doesn't really matter. You can still just write it. You can write the negative out front. So that these are actually, they have the same answer. It doesn't matter if it's negative 3 over 5 or 3 over negative 5. Now, if you wanted to do that on your calculator, like I said, we haven't talked about decimals yet, but you should get negative 0.6 if you change it into a decimal, because 3 divided by 5 is 0.6, and so it's negative. So yeah, but you can just write the, if you have one number divided by another number, you can just write it as a fraction. So let me do an example where the two numbers maybe have something in common, like 6 divided by 8. Well, like I said, you can just write this like that. But usually when the answer is a fraction, we'll write it in simplified form. So we have to try to simplify this. So I'm going to try to simplify 6 over 8. Well, that's where the greatest common factor comes in. Now, I showed you in one of my previous videos the Euclidean algorithm. One way you can find the greatest common factor between two numbers is you could take our two numbers are 6 and 8. You can just list out all the factors of 6 and 8. Then you look for one that's in common. Well, one's in both of them. 2's in both. Those are the only thing that are in both. The greatest of 1 and 2 is 2. So 2 is the GCF of 6 and 8. So you can divide each number by 2. So 6 divided by 8 is 3 over 4, which is 0.75 once we start talking about decimals. Alright, so that's the operations with integers, multiplication and division. I still expect you obviously to read the sections that talk about this and to do any homework I assign. And keep track of announcements in case I decide to actually do a class online, which I might do like once a week or twice a week. Probably not 3 times a week, even though we normally do meet 3 times a week. I think this online is probably less helpful anyway, and I would like to guarantee more people come to the virtual classroom. So I think if I just hold it once or twice and say, you know, it's important. Or I could do it 2 or 3 times a week and make it optional. Like if you don't think you need to, if you think you can learn what you need to learn by just doing the homework and looking at the book, coming to virtual office hours and maybe calling me to ask a question or emailing me, then you can do it that way. So in the next video, I'm actually going to start talking about operations with fractions, or I guess I should call it rational numbers, but all the rational numbers that we're going to look at are also fractions, so operations with rational numbers, fractions. I'll tell the difference between what it means to be a rational number and a fraction in the video. So.